Okay, good evening. This is the report from Europe, and I try to follow the three charges we received from our chairman. First, I will give you an overview of accelerator facilities in Europe, and I would like to give you a broader picture than just those we use for particle physics experiments, because we have a large number of accelerators in Europe operating, small accelerators, mid-sized accelerators. We have several third-generation synchrotron sources already operational in Europe. We have, of course, high energy and high intensity machines. And in addition to those institutes who operate accelerators and do accelerator R&D, we have institutions who do only accelerator R&D. So if I try to put those institutions on the map of Europe, you see this pattern. And I try to show you that we cover very nicely the whole, more or less the whole of Europe, with in red those institutions where particle physics experiments are done. In yellow, those institutions with these many small and mid-sized accelerators. In green, institutions with important accelerator R&D. And in blue, the third-generation synchrotron light sources. If I miss an institute, please don't get upset. Just send me the information that I will update my slides. Now, I'll have not much time, so we'll go only through the particle physics relevant accelerators and institutions. And of course, first of all, we have our central laboratory CERN with LHC. There is also the SPS, which is not only used as an injector for the LHC, but also as a machine with its own physics program. The same is true for the proton synchrotron. And I probably like also to mention the antiproton decelerator, although it's a decelerator, not an accelerator. And finally, maybe the low energy ion ring. So CERN is an international laboratory, but there are also national laboratories in Europe. One is the Paul Scherrer Institute in Switzerland with its flagship machine, the proton cyclotron. It's an old machine, but nevertheless, it's a record machine with 1.4 megawatt. It's a proton machine. Another national laboratory is the Laboratorio Nazionale de Frascati in Frascati, close to Italy. Their flagship accelerator is the Daphne E+ and minus collider. Again, a record machine with luminosity in the order of 4.5 times 10 to the 32 and currents exceeding 1 amp. I would also like to mention the electron linear accelerator in Frascati and probably also the Spark high power injector. I have also DAISY in red on my map, although I know that at the moment there is no operating accelerator-based particle physics experiment in DAISY, but I would like to keep it here because of its importance for the test beam facility, which many of us use to test detectors. And finally, GSI Darmstadt. I know GSI Darmstadt is already more in the field of nuclear physics or hadron physics, but let me still mention it here with the heavy ion facilities, linear accelerator, synchrotron, and storage ring, and the FEA complex under construction. So this is Europe, a view of CERN member states, but I think I ought to cover also one more country here, because it would otherwise fall into a gap and wouldn't like that. And this is the Russian Federation and the Joint Institute for Nuclear Research in Dubna. I have three reasons to cover it in my talk. The first two are political. The Russian Federation has, about a year ago, applied to become associate member of CERN. And as far as I know, the negotiations are well underway, and soon this status will probably be given to Russia. Second, also the Joint Institute for Nuclear Research, which is also an international organization like CERN, is discussing with CERN a reciprocal observer status. And thirdly, it's just a personal view. I believe Russia belongs to Europe. Now, so if you allow me to mention the centers in Russia which do particle physics, of course, there is the International Center in Dubna with the machine, so-called Nucleotron, which soon will become the injector for the Nika complex. South of Moscow is HEPHY-Vienna with their proton synchrotron running the order of 50 to 60 GeV. And finally, I probably should also mention ITEP Moscow with the TWAC facility, although I think it's at the moment under refurbishment. And now, if you allow me, I draw your attention far to the east, even with the danger that I step on the toes of my Asian colleagues. But the Butker Institute is not only important because of their operating A+ and minus machines, but also because of their many, many significant contributions to hardware expertise to almost all big accelerator projects in the world. So I stop here with this overview and I move to the second task I was given to explain the vision of community for future accelerators. Now, when I read this mail from Tatsuya, I thought, oh my God, how can I pretend to give the vision of Europe? This will probably be the end of my career. But after all, it's not so difficult because in Europe, we have more than a vision. We have already a strategy. The first strategy was defined 2006 by the CERN Council. And I have official in quotation marks because, of course, there were strategies before. But this is the first official strategy defined in a period where the CERN Council put more emphasis on its role of coordinating Europe's particle physics at large and not only the CERN laboratory. The strategy was updated 2012 and 2013. We followed a process which was quite similar to the one which was presented by my colleagues from the US, with one big difference. I come to that in a minute. We had an open symposium. We collected input from the community. We produced a scientific briefing book, which, by the way, is still available if you want to have a look. And then we had a drafting session in Erice. But finally, this strategy is already approved by the CERN Council. It was approved in a special European strategy session. So this is approved by the governmental organization, governmental representatives, including the funding agencies. I think this is the big difference to what we have heard from the US. So I will go with you through the main points of the strategy update. And at the same time, I will show you that we have already implemented all the points of the strategy in Europe. Now, the strategy in Europe, the strategy update, of course, had to find a balance between maintaining the diversity of the scientific program and, on the other hand, to set priorities for the large-scale facilities where we have to set priorities because we are living in a world of limited resources. So the strategy update identified, finally, 4 high-priority, large-scale scientific activities which should be pursued. All 4 of them should, of course, be pursued. And I will show you during my talk that there is a logical timeline, which means that the peak investments are not at the same time. And, of course, there's also a difference in the scale of the involvement. So number 1 is priority list. This is, of course, the top priority is LHC and high luminosity LHC. And here the strategy recommends to go to the full LHC upgrade, meaning a target integrated luminosity of 300 inverse femtobarn. Now, don't think that this is an easy project. There are major investments necessary for the LHC machine, interventions and investments, large upgrade projects for the experiments. So contributions from the other regions are absolutely crucial. And I would like to say that this, I believe, is the next big challenge for particle physics worldwide. And in a timeline, this clearly is the program for the near future. Number 2, the implementation is well underway, and we made a big step in June when CERN Council accepted the medium-term plan of CERN, medium-term plan up to the year 2019, which contains already part of the high luminosity upgrade. There's also large progress by the experiments, and as chairman of ECFA, I cannot resist to point to the 2 workshops we are organizing with the community. One happened last October, and the next one will happen this October. I move on to number 2 of the high priority items. These are design studies and R&D for post-LHC projects. And the strategy reads, CERN should undertake design studies for accelerator projects in a global context with emphasis on proton-proton and electron-positron high-energy frontier machines. And here I would like to use the word vision. In Europe, we have a vision for CERN's future, and we see this vision as CERN being the laboratory at the energy frontier. And consequently, post-LHC machines are either CLIC, high-energy LHC, or the FCC complex. But of course, more scientific input is needed before one can decide on the next large machine at CERN. And in a timeline, of course, this is the long-term program, but we have to make the studies now. We have to prepare now for physics beyond probably 2035. The implementation is twofold of this part. First of all, we continue our study on CLIC. Now, this is the two-beam accelerator scheme. You see a sketch of a possible footprint of CLIC within the Geneva area. A conceptual design report was published, and the study continues at CERN in many laboratories in Europe and worldwide. The second part of the implementation is the newly launched international study on future circular colliders. And this is a study, a 5-year study with the following scope. First of all, it is about a proton collider with a target energy of 100 TeV. And the crucial R&D item here clearly is the dipole technology. And the dipole technology will finally define the circumference of this machine. With about 16 Tesla dipoles, we would need about 100 kilometers. If 20 Tesla dipoles are available at the time of construction, we could live with 80 kilometers. And this proton machine will define the requirements for the whole infrastructure. In addition, a second work package of this study, we study an electron-positron machine with a target energy of 350. And this could become a possible intermediate step, something like we had before, LEP and LHC. Thirdly, as an option, we include also a study on hadron electron or ion electron. And of course, the infrastructure in the Geneva area is the big part of this study, and you see a sketch on how this machine could be placed close to CERN. Third bullet is the International Linear Collider. And here the strategy says there's a strong scientific case, and European groups are eager to participate. Europe looks forward to a proposal. I think this is a very strong statement from Europe in favor of the ILC. And if I remember the discussions we had in the strategy group, the strategy group supported the machine with an initial energy of 250 GeV to perform Higgs studies, but sees the energy upgradability of ILC as a very big asset. A TDR was submitted in time for our upgrade process. And if you look in this TDR, you will see that the European community is the largest in this organization. The implementation continues, is underway. There is work on the ILC machine and detector, continues in many institutions with support at CERN, for instance, by hosting the Linear Collider Directorate. And now, here comes a valid question. Can Europe afford participation in the ILC on top of high luminosity LHC, on top of studies for post-LHC machines? My answer to that is yes, because we see this ILC as a medium-term program. The big investments from Europe to the ILC will come after high luminosity LHC and before the next large facility at CERN. Fourth and last high priority item of our strategy is the Neutrino Program. And here the strategy recommends to reconstitute a neutrino physics activity at CERN in order to provide technical expertise, support, and focus for Europe for a forthcoming experiment which not necessarily need to be hosted in Europe. And the implementation of that has also already started by CERN setting up the Neutrino platform. And the Neutrino platform at CERN will consist of an extension of the North area, SPS North area, with a charged beam for detector development, detector R&D for neutrino experiments, here mainly the liquid argon technology, where a lot, if not the expertise is in Europe, and finally in preparing detectors at CERN for transport installation in the US. These are the prioritized items. And then our strategy also lists those items which we think are important but need not to be prioritized. And of course, these are theory. These are the unique small and mid-sized experiments. This is instrumentation, state-of-the-art infrastructure at CERN, computing, and finally, those experiments in the overlap with the astroparticle physics community and the nuclear physics community. I don't want to go through a summary of our strategy. Just let me conclude. I believe we have a clear vision and a strategy. The program we have drawn up is challenging, but it's not unrealistic. And I hope I could show you that we have already fully implemented the strategy. And the last comment, the next update of this European strategy is foreseen in about 5 years. Now, the third point I was asked to address is the opinion of the European community on globalization and global coordination. And here I think I can be quick. I just want to draw your attention to four facts. First, look at the long tradition the European community has in participation in projects outside Europe. Few examples are the Zero CDF at Fermilab, Babar, SLAC, Bell and Bell 2 at KK, and the neutrino experiments in Japan and the US. Second, LHC and even more high luminosity LHC are global projects in Europe. You have seen, you know there is a large involvement of European colleagues in the ILC plant in Japan, and there is this emerging support for the Neutrino Program in the US. And the fourth fact, I would invite you to read the strategy update carefully. You will find many statements underlining the importance of internationalization. And there is a particular statement, Statement L, which is an outcome of Working Group 2 of the European Strategy Group, which discussed the organizational structure for possible European participation in global project. And it says that, first of all, future major facilities in Europe and elsewhere require collaboration on a global scale. And then it concludes that CERN should be the framework within which to organize a global particle physics accelerator project in Europe, and should also be the leading European partner in global particle physics accelerator projects elsewhere. So if you take note of those four facts I have shown you, I think there shouldn't be any doubt left that European particle physics, and let me stress here very clearly, and also the funding agencies in Europe support and engage in the internationalization of large-scale facilities across continents. And I finish with a trivial statement, but I think it's true. Physics is universal, and particle physics is global. Thank you.
Okay, thank you, Manfred. Before we proceed to the next program, I would call for any questions or comments. Yes, there's one there.
Since the capabilities of an ILC and an FCC EE are sort of similar to first order, if the ILC would go forward, would that impact the decision whether to go straight to FCC HH or still to do the circular plus C minus?
These are two issues which you cannot compare on the same footing. The ILC is a machine which is well developed. We have a TDR and is more or less ready for construction. The FCC is a study we just launched. We do not know how feasible it is, what it costs, etc. So there is no comparison between those two issues.
Okay, there here one, and yes, Alain.
I'd just like to relay an announcement made by the Swedish government last Friday that the European Spallation source will now go ahead. It's the last brick in the construction of the financing was made recently by Germany joining the 11%. So this will primarily be an accelerator facility for neutron physics, but there are also particle physics programs being proposed like neutron, anti-neutron, oscillation and neutrino superbeam physics. So there could be an additional European component there. Thank you.
Thank you for the comment. Then the last point from Alan.
Yes, is that working?
I think it's on.
Is it working? Yeah. Okay. Well, let me slightly put a little flavor to what you said about the FCC EE versus the ILC. I think these are two machines which are quite different from the point of view of the levels of luminosity and the luminosity picture. In particular, FCC EE is a Z factor, very large luminosities at the Z. As far as the readiness of the project, you have to take into account that the ILC is a risky project in a way because it's been a long time since the SLC was reaching 6 to 30 luminosity, and now we're talking to go up by 3 or 4 orders of magnitude, while the E plus E minus circular machine is based on a long experience with E plus E minus circular machines. And so I think it is correct to engage in a comparison and to have open discussions about it, and I think we should. It will even reinforce the case of the ILC to have been honestly compared rather than to brush off the discussion, I believe.
Okay, thank you for the comment. Okay, so I would like to ask thanks to 3 speakers first. Thank you very much.